Hello Year 10, this is our lesson on hormones and the endocrine system. Last lesson we looked at the main glands in the body and the hormones that they produce. If you remember, the endocrine system is made up of the glands and the hormones that they produce. And those hormones are taken around the body in the bloodstream. These, remember, were the 6 that you had to know. So that's the pituitary, the thyroid, the pancreas, the adrenal glands, and in the man it's the testes, and in the woman it's the ovaries. Today we're going to be focusing on the role of the pancreas. So going back to last lesson then, we learned that the pancreas produces the hormone insulin, and that controls blood sugar, or the proper name for sugar, glucose levels. So if we eat any carbohydrate, it gets broken down in the digestive system into glucose. And if you remember, carbohydrates are that group of foods that give us energy. And if you remember, carbohydrates like starch, the thing that you find in rice and potatoes, are made of these really long molecules. And we have to break them down into much smaller molecules so they can be absorbed into the bloodstream. So if you have a look at the diagram at the bottom here, here's your starch molecule. It's quite a large molecule. It wouldn't fit through the walls of the intestines and into the bloodstream. And so we have to break it down into these individual glucose molecules, which are now going to be small enough to fit into the bloodstream. Now the glucose is in the bloodstream, we can take it wherever it's needed in the body. Again, this is a lovely recap of a previous unit, because we learned that in every single cell in the body, glucose is taken in, combined with the oxygen we breathe in that process that we call respiration. And there's the respiration equation there. So glucose plus oxygen gives us carbon dioxide plus water, and of course it releases energy that we need to live. So after a big meal, we're going to end up with a lot more glucose or sugar in the bloodstream than we need. We have to get rid of this excess sugar. In the long term, high levels of sugar or glucose in the blood can cause damage to the blood vessels, the nerves, eyes and kidneys. So we need to get it out of the bloodstream. So this is where the pancreas comes in. We already know it releases the hormone insulin, and the job of insulin is to get glucose into the cells. Insulin is really important. It allows the glucose to pass inside the cell through that membrane. If we've had too much glucose in our bloodstream, it goes into our cells, and anything left over is converted into glycogen, which is stored for later. So a few hours after you've eaten, if you need a bit more energy, we can get that glycogen out of storage and turn it back into glucose. So this diagram gives us an idea about the different types of human glucose levels you can get in the blood. The middle section shows us what it should like if it's normal. We should have enough glucose in our bloodstream to keep us going. We need enough energy to keep going. On the right hand side, we've got an example called, medically, hypoglycemia. This means that there's not enough glucose in the bloodstream. And of course we need glucose for energy. Without energy we could faint or pass out, for example, because we just can't keep going. Over on the left hand side is hyperglycemia. And this is what happens when you have too much blood sugar. Now, if that's happening, it suggests that the insulin isn't doing its job. It's not allowing the glucose to pass into the cells. So both hypo and hyperglycemia are equally dangerous. So this graph shows how blood glucose levels change after a meal. So Bernard's eaten his meal at 1 p.m. and there we are at 1 p.m. He's had something to eat. And as we can see, after his meal, those carbohydrates have been broken down into glucose, and so the amount of glucose in his blood has increased. So as Bernard's meal is digested, the amount of glucose in the bloodstream will continue to increase. As the glucose levels in the blood increase, the pancreas will release insulin. And obviously the job of the insulin is to allow that glucose to pass into the cells. As the glucose moves into the cells and out of the bloodstream, then the amount of glucose in the blood is now going to go down. Eventually, by about 5 p.m, we've got our glucose levels in the bloodstream are back to normal. They're back to what they were before the meal. Earlier, I mentioned that you could end up with too much sugar or glucose in your bloodstream. If insulin isn't removing the glucose from the blood and allowing it into the cells, then this is going to be really dangerous, because not only could the blood sugar damage your blood vessels, but you need that glucose in your cells to get the energy to stay alive. Type 1 diabetes is a condition where the body either doesn't produce enough or maybe doesn't produce any insulin. And if you have type 1 diabetes without insulin, then you can't get energy to live. So this is a condition which is really serious. Type 2 diabetes is a condition where the cells don't respond to insulin. So even though the body might be producing it, it's not doing its job of letting the glucose into the cells properly. So on this graph, we can see the difference between blood sugar levels for somebody who has diabetes and somebody who doesn't. So on the bottom graph there, we've got Bernard again having his meal. And as you can see, the blood sugar levels will go up and then they'll go down again as time goes on, because his body responds to the extra glucose by producing more insulin, and that insulin removes the glucose from the bloodstream. As you can see with Stanley, these levels go up and they don't really drop off very much at all. So if you look at the amount of glucose in Stanley's bloodstream after his meal compared to when he started his meal, then you've got a massive difference there. So that glucose is staying in the bloodstream. So if Stanley has diabetes, he probably has to inject insulin in order to get that glucose into his cells. So as usual, I've got some vocabulary at the end of the presentation so you can check any of the terms that you were unsure about.